Hello friends, welcome back to Rising Mathematics. In our previous video, we have seen the concept of a right increasing function on a time scale. In this video, we are going to prove a theorem based on this concept. Statement of the theorem is, suppose f is a function from time scale to set of real number which is differentiable at a point t0 which is not a maximum point of the given time scale. If delta derivative of function f at point t0 is strictly positive, then function f is a right increasing function. We will start our proof. Assume that delta derivative of function f at point t0 is strictly positive. Then for this point t0, we have following two cases. So first case is point t0 is a right scattered point of the given time scale. Then for such right scattered point t0 of the given time scale, we have delta derivative of function f at point t0 equals to f of sigma t0 minus f of t0 divided by sigma t0 minus t0. We have seen this result in our earlier video. Now we know that f delta at t0 is positive, so this whole term will be positive. But note that denominator is always positive since t0 is right scattered point, so sigma t0 will be strictly greater than t0. So numerator must be also positive, that is f of sigma t0 minus f of t0 is strictly greater than 0. So from here we have f of sigma t0 is strictly greater than f of t0, and thus our result holds in the case t0 is a right scattered point. Second case is that point t0 is a right dense point of the given time scale. Then for such right dense point t0, we have delta derivative of function f at point t0 is limit t tends to t0 f of t0 minus f of t divided by t0 minus t. We have seen this result in our earlier video. Now if we consider this limit, we have for epsilon equals to f delta t0, there is a neighborhood u of point t0 such that modulus of f of t0 minus f of t divided by t0 minus t minus f delta t0 is strictly less than epsilon for all points t in the neighborhood u of point t0 which are different from t0. Now if we consider this, we have again two possibilities. So first possibility is that this term is positive and it is less than epsilon, which is f delta t0, and second possibility is that this term is negative, which is also less than epsilon, that is f delta t0. So we will discuss both these possibilities one by one. So first possibility is that this term is positive and it is less than epsilon, which is f delta t0. So further simplification gives f of t0 minus f of t divided by t0 minus t is strictly less than 2 times f delta t0. We will call this expression as 1. And second possibility is that this term is negative, so here we have given minus sign, and it is less than epsilon, that is f delta t0. Further simplification gives minus of f of t0 minus f of t divided by t0 minus t is strictly less than 0. Now because of this minus sign, this inequality will be reversed and we get f of t0 minus f of t divided by t0 minus t is strictly greater than 0. Then combining this expression 1 and this expression 2, we get 0 is strictly less than f of t0 minus f of t divided by t0 minus t is strictly less than 2 times f delta t0 for all points t in the neighborhood u of point t0 which are different from t0. Now observe this thing. Here f delta t0 is positive due to our assumption. So this term will be positive, and also from here we have this term is positive. So overall this term is a positive number. Now here if we consider all points t from neighborhood u of point t0 which are different from point t0, so here this denominator will be negative since t is strictly greater than t0. But we have discussed that this term, whole term, is a positive term, So we must have this numerator is also negative. That is f of t naught minus f of t is strictly less than 0. So from here we have f of t is strictly greater than f of t naught. So result is true for the case point t naught is a right dense point also. And this completes proof of the given theorem.